Boom! Yes folks, Hume here again. How are you going? In this video I'm going to deal very shortly with a topic that comes up for the first time in section 2 in the maths. This is a part of functions. You know, in the maths we have regular functions in section 1, and then in section 2 you go a little further in the functions, and then in add maths you go a little further in the functions, and then in keep you go a little further, right? And this thing is something that also would show up in a lot of maths courses at university level, tertiary level, UE, UTT, USC, right? Different tertiary institutions in Trinidad and Tobago and outside of Trinidad and Tobago. You know, as the people on the radio used to say when I was small growing up, local, regional, and international. All right? So that is the topic of finding out when a function is equal to 0 and when a function is undefined. And this applies to what we refer to as rational functions in the language of mathematics. All right? So you have a rational function. Let me say a random function. Let me say the function is f of x is equal to 2x minus 7 over 3x plus 2. All right? That is what we refer to as a rational function. Rational because we have a ratio. Something divided by something as a ratio. So anytime you hear reference being made to a rational function, what that means is that you'll have a numerator and you'll have a denominator. So you see how we're introducing the terms now. Alright? So let me deal with 0 first. Alright? We want to find out that f of x is equal to 0 when, and yeah, question mark, and you're saying that fx is undefined when, and yeah, right? So those are two separate conditions that we like to consider for rational functions. We want to know where the function is equal to 0, and we want to know where the function is undefined. The precise implications of that is something that is beyond the scope of this video. That is something that you'll more deal with when you're dealing with keep. People in Form 6 and thing will deal with that. Alright, but since this video is more for CSEC, Form 5 and below, and for entry-level university, let me stick to that level now. Alright? Now, the function is equal to 0 when the numerator is equal to 0. And the reason for that is that, in general, 0 divided by any constant is equal to 0. 0 divided by any function is also equal to 0. So in other words, it doesn't matter what you have in the denominator. If the numerator is 0, then whatever it is you have here will end up being equal to 0. So if you want to find the value for which any rational function is equal to 0, all you have to do is take the numerator and equate the numerator to 0, and that will give you your answer. So using this same function here, you would say that f of x is equal to 0 when the numerator is equal to 0. And if the numerator is equal to 0, it means then that 2x minus 7 is equal to 0, in which case 2x is equal to 7, and x is equal to 7 over 2. End of discussion. Alright? On the other hand, if we want to talk about when f of x is undefined, we wouldn't talk about infinity and all them things. We will leave that for the people in Cape. We will leave that for the people who are doing their university course in maths. Right? Suffice it to say that if you try to divide anything by 0, you'll get an error. So if you have a calculator with you, or you have access to a calculator, pick it up and try to divide anything by 0, and you'll get undefined. So for example, using the same pattern that we just employed with the first part of this question. All right. Let me see. Let me change the color of the ink now. All right. Any constant divided by 0 is what we refer to as undefined. Like everything else, we could go into more detail with this, but that is, here is not the place for that. This video is not the place for that. All right. And by the same token, any function divided by 0 is also undefined. So whether I have a constant divided by 0 or some other entity divided by 0, once you try to divide by 0, you'll get undefined. And if you try that on a calculator, you'll get what we refer to as you'll get an error on the calculator. The calculator can't do that because it can't be done using regular conventional mathematics. We know that have other branches of mathematics where you go into more detail with that. So anytime you have to determine the value for which a function is undefined, then all you have to do is find, in fact, let me write it out just as we did there just now. So you say that f of x is undefined when the denominator is equal to 0. And if the denominator is equal to 0, it means then that 3x plus 2 is equal to 0, in which case 3x is equal to minus 2, and x is equal to minus 2 over 3. So this function is undefined for x equal minus 2 over 3. This same function is equal to 0 for x equals 7 over 2. End of discussion. Now, as we like to do so often, we raise the level of complexity. Most of the past papers I have seen in CSEC, almost all, you would get a function like this, and almost always the functions, the functions involved inside the original function are linear functions. So 2x minus 7 is a linear function. 3x plus 2 is a linear function, which means then that you'll only get one value of x for which the function is undefined, and by the same token you'll only get one value of x for which the function is equal to 0. So here what we're going to do now. Let me change the functions. Let me change the internal functions and make the thing a little more tricky. Alright? So if we say that f of x is equal to, let me put two quadratics now, because we're doing maths. Right? Of course, if we were doing add maths, we could raise the bar even higher. But we will leave that for another time. Alright? Let us say that f of x is equal to x squared minus 3x plus 2 over 2x squared plus 5x minus 12. Alright? And you get this in our number 8 in CSEC. You know CSEC squeezing people a little more now in terms of the level of the questions. Right? Because let me face it, we have 50 years of past papers out there. Right? You know, we like to exaggerate a little bit. We have 55 years of past papers. And people doing past papers. Now the truth and the fact of the matter is that if you do all the past papers that are available, and you do them in a conscientious manner, you're not just writing out solutions just to say you do a past paper. If you do the past papers properly and you use them in the way in which they were meant to be used, you have a better than even chance of not having any particular difficulty with the exam. Alright? Because there are not too many different ways in which you could ask somebody what 2 plus 2 is. Right? There are plenty of ways, you know. But if you do enough work, it wouldn't matter how they come. 2 plus 2 is equal to 4. Alright? So you realize everybody have past papers, so what you do? You twist up the questions and they make it more interesting. So in other words, people are forced to think a little bit now. And that is what I try to do with my students. So even when we're doing past papers, I try to do it in a way where we're thinking, we're thinking, we're not just cramming solutions and writing answers. Because if you do that, you're almost guaranteed to be put in a situation at some point where you get a question that you never see before. And even if they give you a lot of hints from step to step, you wouldn't catch it because you're so stuck in this mindset of doing stuff that you're familiar with, that when they put you outside the box and they tell you, well, organize yourself, your brain just shut down and you freeze. Alright? So if you get a question like this in a CSEC past paper, which is entirely within the bounds of possibility, there is no good reason why they can't give it this, then the thing is this. Now, here how the question would run. Here how the question would run. If you get a question like this in CSEC, and this is what I'm trying to show people all the time, chances are the question would say, find the values of x for which the function is equal to 0. Let me write it out now. Let me write it out just to make the point. They would say, find the values. In some cases, they'll put the s in comma in brackets of x for which f of x is equal to, is 1, is a, equal to 0, and 2. Undefined. Right? Yeah. Now, you read a question like this, and it tells yourself it's hard because you never see this, and we didn't get that in the past papers. Of course you didn't get it in the past papers, because they didn't do it before. But if you read the question and you see values, and you get a sense of where that's coming from, and you see a whole quadratic in the numerator and in the denominator, well then tell yourself it's the same procedure now. The only difference, of course, is that if you make a quadratic equal to 0, you get 2 answers. So in other words, by putting the word values, whether they use the actual word values or they put the s in brackets at the end, they are giving you a very loud hint that you're getting 2 values. And if you know that in solving an equation you get 2 values, then you know you're referring to a quadratic. And you know that if you equate a quadratic to 0, boom, you have 2 solutions or 2 roots, to use the language of ADMATS. Alright? So in other words, the only thing they didn't do is walk up to you and tap you on the head and say, hey, so is the case. But they give you a loud hint here. Alright? So I want to encourage students to think. Don't go in the exam like a robot. You go in the exam like a robot, you will get catch, because they bring in the questions like that now. And if you ask me personally, I love it. I am loving it. Because maths is not something that you do by rote. You have to understand as much as possible and be able to think on your feet in the moment. Right? It is not always about rehearsing a particular set of steps and just going out and repeating what you rehearse. Sometimes it's a matter of drawing on the foundation from different parts and putting something together on the spot. Alright? So if we have to find the values of x for which the function is equal to 0 and for which the function is undefined, then all it means is that we do the same thing that we just did for the linear functions on top and bottom here. The only difference, of course, is that we have a quadratic. So in the case where the function is equal to 0, we know that the numerator is equal to 0, which is to say, and I'm saving the space for the big worker now, which is to say that x squared minus 3x plus 2 is equal to 0. You have a quadratic here that could factorize. So I'm just going to give you the answer. I'm not going to go into the details of how we do the factorization. That's for another time. Right? We have videos on that too. Right? We factorize and we get x minus 2 into x minus 1 equals 0. In which case, x is equal to 2 and x is equal to 1. Again, how we get from here to here is a separate discussion. Here is not the time or the place for that. That is what happens when the function is equal to 0. To find the values of x for which the function is undefined, you equate the numerator to 0. So you take same 2x squared plus 5x minus 12. You factorize, you get what? Let me see. 2x into x. 2 by 4 is 8. Hold on. 8 and 3, 8 minus 3 is 5. So, you have a 4 in there somewhere. Right, so you have a 4 here, and you have a 3 here. 8. Right, 8 minus 3. Right, again, we're not going through the steps of how we get from here to here, right? Let me just double check in. 8x minus 3x is 5x. 4y minus 3 is 12. Right, so 2x minus 3 into x plus 4 will be equal to 0, in which case x is equal to 3 over 2 and x is equal to minus 4. Alright? And that's it. So again, I want to, and let me take it even further now. Let me take it even further. Watch. If I change this 12 to 13. Alright? If I change this to minus 13. And I change this 2 to 7. By doing that, what I have now done is ensured that these two quadrics are not factorizable. In other words, the process is the same. Numerator equal to 0, denominator is equal to 0, but you can't factorize it. Alright? Here how the question for that will look. And I'm rubbing off everything here now, right? You can take your notes, you can rewind, pause, stop, and write if you need to write. Alright? The question for this would read as follows. And I'm writing it out again, just to demonstrate the kind of clues and hints to look out for when you're doing the people exam. They would say, let me write it on this side. They would say, find the values of x. Find the values of x for which the function f of x is dot a equal to 0 and b undefined. And here what they're going to tell you now. Giving your answer, I'm writing it here for emphasis, giving your answers to 2 decimal places, right? Only excuse the penmanship a little bit, right? Only go hear exactly what I say. All right. So you go in the people exam and you see the question. You get a function. Listen, man, if I was setting exams, this is the kind of questions I would set. Right? They tell you, they give you a function, a rational function, and they tell you to find the values of x for which f of x is a equal to 0, b undefined. Watch it now. Giving your answers, yeah, I know the penmanship is too hot right now, right? Giving your answers to 2 decimal places. Ladies and gentlemen, this here is a clue. Right? From the time you see this in our CSEC number 8, Relations and Functions section 2, don't even think about trying to factorize. that will be an exercise in futility. You will waste time. Once you see that that is them walking up to your face, walking up to you and slapping in your face and saying, use the quadratic formula. In other words, when they put this, they are saying to you that the expressions cannot be factorized, and insofar as you can't factorize, then you have to do something else. At the level of CXC, what you have to do is use the quadratic formula, which of course we're not going to do in this video. I have a whole separate video on that too. Alright, so we took one concept and we took it through 3 different levels. Different levels of the thing, as I like to tell my people all the time, in a variety of different contexts. We started off with a rational function where the numerator and the denominator were both linear expressions, which meant that if we had to find the values of x for which the function was 0 and undefined, it means that in both cases we would only have one value of x for which the function was 0 and one value of x for which the function was undefined. And then we took it up a notch and we used quadratic functions in the numerator and the denominator, so that if we had to find the values of x for which the function was equal to 0, we ended up with 2 values of x. And if we had to find the values of x for which the function was undefined, we also ended up with 2 values of x. And then we took it up a notch even further, and we made the functions in the numerator and in the denominator to be such that you couldn't factorize them, which now meant that you had to do something else. You had to use the quadratic formula, which is the subject of a different video. So the whole point of me doing this is to open your mind, to alert you to the fact that it doesn't matter if you do past papers from 1956 come down. If you're not prepared to think, you will have problems. You'll go in the people exam and see a question, and when all that was necessary was just a little thought, a little patience, slow yourself down, don't rush for the pen and answer the right, and you miss the whole thing, and then you come out of the exam room complaining how the question was hard and how they bring add maths in the exam and rah 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 rah. No. Set yourself up from now to think, and once you set yourself up to do that, you will understand immediately that you have to prepare as much as possible. And the whole point of your preparation is to give yourself the tools so that you could think on your feet in the exam under the pressure of a clock on the wall ticking down. Alright? So that is that where this particular topic is concerned. I trust, hope, and believe that you have been suitably edified. And if that is the case, then come back. We have more things coming in now. And we have things that we put on already. You could go and check it out. And when you're coming back, bring somebody with you. Alright? We have plenty more to come, man. Boom!